Hey, hey.
Okay, so if we are ready, then we can begin
Yes.
today's lesson. Okay, great. So, can everyone see the screen right now? Okay,
Okay.
so today we will be learning about light images, magnetism, states of matter, and the water cycle. So, yeah, so we will learn about light refraction, dispersion, and reflection. We'll learn about the images, the real image and the virtual image. We will learn about magnetism. We will learn about the states of matter, the liquid pressure, and the water cycle. Okay. So first off is light. So the topic that we will learn about light is called light refraction. So light refraction is the bending of light as it passes from one medium to another. And this is caused by the change in its speed. So when the speed of the light changes, the direction also changes. And you can think of light refraction as, well, refraction means bending. So the term means just the bending of light. An example of this is when objects in water appeared bent or distorted because the light rays from the object bend as they pass from the water into the air. So you can see some example pictures on the right. And on the top, you can see the light is passing through this glass. And since air and glass are different mediums, meaning different um, places where lights can pass, you can see it bends a little bit. Same with water. The density of air and the density of water is different, so it appears bent. Let's look at this video, which shows some parts of light refraction and why that happens. So here is the video.
This isn't just any chat, it's ClickUp chat. Sure, you can tag your team. Now we will learn about the behavior of light.
Okay, yeah. So we will watch until there. So we've looked at how light refraction is different um, across mediums. And we have learned that it bends toward or away from the normal line. So when light goes from air to water, it slows down because water is more dense. Right? So medium, different mediums, if you don't know what this term is, it's basically just a space where light or sound can travel. So an air is a medium, water is a medium, even solids like glass is a medium. And the normal line that I'm talking about is a straight line drawn perpendicular to the surface. So what this means is that when light hits this surface right here, then the normal line will be just this line over here. So it's just a imaginary line that you can draw as a reference to see where the light bends. So if we look at this picture, on the left, this is a case where light travels from a less dense medium to a denser medium. So it goes from air to water. Air is less dense than water, meaning that in a certain space there is less air particle than water. So light slows down. It bends towards the normal. So over here, when the light hits the surface, it doesn't go straight down. It's not going straight down like this on its path. Because light is slowed down, it moves towards the normal. So it goes down a little bit. The light bends this way. So towards normal means towards this vertical line, this straight line. That happens when the light goes from a less dense medium to a denser medium. And the object actually appears to bend toward the surface. So that's a little bit different. So we looked at this picture here. Although light bends down, the object looks like it's going up to the surface. And over here on the right, this is a case where light travels from a dense medium to a less dense medium. So in this case, lights bend away from the normal. So the light is supposed to go this way, right? But it bends away from the normal, this normal line. So it bends away from the normal because this material of water is less dense than the material of glass. So light bends toward the surface a little bit, but then the object looks like it's bending away from the surface. You can always think of the object appearing as opposite to the bending of light. So I hope this makes sense. And don't try to maybe think of it as too difficult, because I think there were only a few questions on this on the exam. So just think of light going from less dense to denser medium is bending toward the normal, and light going from dense material to less dense material is bending away from normal. So yeah. If this makes sense, let's try to answer this question. When a ray of light travels from a dense medium into a denser medium, the light does what of the following? Does anyone know the answer to this question? Yes, I think you are correct. Great job. The answer is A. It bends toward the normal because we're going from a dense medium to a denser medium. So this is the case of air and water, right? So air is a less dense medium, and glass, for example, is a denser medium. So the light is supposed to go over here, but it bends toward the normal because glass is more dense and the speed decreases. Yeah, and this again is the normal line, so the light bends toward the normal line to the left. Yeah, great job. Now let's look at the cases of an object. So, when a stick is dipped into a pool of water, it appears to what? Does anyone know the answer? Yes, if you said D, that would be correct. So let me walk through it a little bit. So the object bends toward the surface. So the light moving from air to water is moving from less dense to a denser medium, right? From air to water, less dense to denser. So the light bends toward the normal. So if this is the normal line, the light bends toward the normal over in this direction to the left. But it doesn't end here. The light bends away from the surface. If you said B, then you might be confusing the object with the light. So, yeah, the light bends away from the surface, but the object appears to bend toward the surface. So it is the opposite, remember? The object that we view acts opposite to the way the light bends. So even if the light bends away from the surface, the object bends toward the surface. So does everyone understand? Is there any questions so far? No questions? Then I will try to move on to this next idea. Well, this is an easier one. It's called light reflection. So we experience reflection in our daily lives really easily. So reflection is when light hits a surface and bounces back instead of passing through it. So this is what happens when you look at a mirror or when you look at a calm water, maybe like an undisturbed, clean water. So when light hits a mirror or water, it bounces off a surface and it allows you to see an object's image. And the angle of incidence equals the angle of reflection, which is just a term that is used to measure the effect of the reflection. But light reflection is what we experience daily, right? Maybe if you look at a mirror, or maybe if you look against a pool of water, you can see yourself. So that is reflection. And there's also light dispersion. Light dispersion is a phenomenon where white light splits into its full spectrum of colors. So red, orange, yellow, green, blue, indigo, and violet. All of those colors are split into its distinct colors. And this happens when it passes through a transparent medium like prism or water droplets. This happens because each color of light bends by a different amount. So the red light bends the least, the violet light bends the most, etc. So you can just think of this as the light being bent in different ways. That's what light dispersion is. But this is not that important. Oh, here it actually shows that light has a very visible light, at least, has this different spectrum in which we can see certain colors. So you can see that Y, when passed through a prism, can show their distinct colors because each of them bends differently with different wavelengths. But let's look at this question. So, a natural phenomenon that illustrates the dispersal of light is what? Yeah, what do you think the answer is? So when does light dispersion happen? Is it a rainbow? Is it an eclipse? Is it a rainfall? Or is it an echo? Yeah, great job. The answer is A. It's a rainbow. So remember that light dispersion is the splitting of white light into different colors when it passes through a transparent medium. So in the case of a rainbow, the light is passing through the water droplets. When it passes through a water droplet, then the light disperses into its unique colors. So that's why you form a rainbow after it rains. So the next question, a rod appears bent when immersed in water. What property of light is demonstrated? So we looked at three properties of light: the refraction, reflection, and dispersion. So, yes, that's right. The answer is A. Great job. It's refraction that is going on here. Yeah. So, refraction is the bending of light. But reflection happens when light bounces off a surface, so it's not really bending, it's bouncing off like a mirror. Dispersion is the splitting of white light that we've talked about. And this last option, the rectilinear propagation, that just means that light moves in a straight line in the same medium. But we've looked at only these three properties of light. And out of them, it is refraction. Yeah, great job. Okay, let's look at this question. An example of a natural source of light is what? Yeah, I'm getting a lot of different answers. I'm hearing a couple A's and couple C's, but the answer is C. It's the glowworm, and that is a natural source of light. So a natural source of light is anything that is not man-made, of course. So things like the sun, the stars, the wildfires or volcanic eruptions, bioluminescence like the fireflies and glowworms that we've talked about. All of those create their own light. Also, things like lightning, lava, or auroras, all of those are natural sources of light, which is not man-made. And an important note is that the moon is actually not a natural source of light because it does not produce its own light. The moon is just a reflection of the sunlight from the sun. So it's not producing its own light. The moon is just reflecting the light from the sun. But anything that creates its own light is called the natural sources of light. So, yeah, I hope that made sense for everyone. So far we've talked about light. So does anyone have any questions about light? Like the properties of light or anything else? If there are no questions, then I'll be moving on to the next topic, which is on images. So, real and virtual images. So, let's look at what these are. So, an image is the picture formed when reflected or refracted light enters your eyes. So the real image is formed when the light rays actually meet at a point. And it can be shown on the screen. So the object is actually there and can be projected, can be shown. And the real images actually often look upside down. On the other hand, we have virtual images. So virtual images are formed when light rays appear to meet at a point, but do not actually meet. So it's like an imaginary object standing in a way. And a virtual image cannot be shown on a screen. It's not something that we can show physically. And a virtual image usually appears upright. So here are some differences between the two. But let's look at this quick video which shows and demonstrates the real image and the virtual image. Okay, so that was a quick example of the real versus virtual image. And we saw some examples by the magnifying glass and the mirror. So here is the real image where it is inverted and where it uses a concave mirror. So concave mirror is a mirror that bends inward like this. It bends inward. On the other hand, there's also the convex mirror, which bends outward. But when we're talking about the real image, we're looking at objects through a concave mirror. So the object looks inverted, upside down, where the light rays meet. So the light rays meet at this single point over here. When the object's light reflects off the concave mirror, it produces a real image over here in this area. But that real image is upside down. So the light from the object bounces from the concave mirror and it converges to a point, and that point is where we can see the real image. Okay, now let's look at the virtual image. So the virtual image is happening when the light bends away from a plane or a convex mirror. And it produces this upright image. So we have, in this case, a plane mirror, just a straight mirror. Just any normal mirror that you would see. But when the light reflects off of this plane mirror, or just a convex mirror too, the light bends straight to produce an upright image. So what appears to look like the tree is over here, but the actual object is over here. And this place does not exist. We're just looking at the virtual image. So you can see that the light rays do not actually meet. The light rays do not meet. So that's why we're not seeing the real image. We're just seeing the virtual image across the mirror. And that virtual image actually does not exist. Okay, so this was a little bit confusing, but I hope by watching this video, it makes a little bit more sense. So this will compare the real image with the virtual image by using a candle and a convex and a concave mirror. So let's see how these real and virtual images are in action. Okay, yeah, we just wanted to look at this image formation by concave and convex mirror. So convex, if you have a convex mirror, it produces a virtual image like this. It's shown in the mirror, but it's actually not there in the back. But if we have a concave mirror, then the real image is shown over here on the screen. And you can see that it is inverted indeed. And it is converged at a point. The lights, all of the lights that bend off of the concave mirror converges to this point. Yeah, so that was real versus virtual image. And here's just a table that shows some of the similarities and differences. So in a real image, light rays actually converge at the image location, but in a virtual image, light rays do not actually converge. In a real image, it happens with concave mirrors or things like camera or image on a projector screen. But we can see virtual images with a plane mirror or a convex mirror. A real image is inverted, but the virtual image is upright. The real image can be shown on a screen, but the virtual image cannot be shown on a screen. So here, of course, the regular mirror that we use produces virtual images because it is upright. if it was a real image, has to be upside down and it can be projected onto a screen. So yeah. Let's look at this question and see if anyone can answer. So the image formed by a plane mirror, this plane mirror, is always what? If you said, yeah, I think I heard D, and if you said D, that is correct. Um, the image formed by a plane mirror is always virtual. So remember, if we have an object over here and it bends off a plane mirror, then we see that the object looks like it's over here. But that does not exist. And that happens because light doesn't converge at a point with a plane mirror. It only happens with convex mirrors. And sorry, concave mirrors for real images. Okay. So yeah, this summarizes the image formed by a plane mirror. It is always virtual. It is always the same size. And it is always upright. Okay. So let's look at this this question. Which of the following characteristics is or are of the image formed in the pinhole camera? So the pinhole camera looks like this over here. So we didn't talk about pinhole cameras yet, or maybe too specifically. So I'm going to show you why some of these options are correct and are incorrect. So pinhole cameras, the objects are inverted. Yes, that is correct. And that's because the object is real. So we have a real image projected by the pinhole camera. So always remember, any sorts of cameras, we can get a clue. What does a camera do? It captures the real image. So we know it's real, we know it's inverted, and we know it's not virtual. What else do we know about pinhole cameras? Well, pinhole cameras form diminished images. That means that the image produced is smaller than the actual object. So we can also check this one. So the answer has to be 1 and 3, right? So it has to be C. Yeah, so this is just introducing some of the properties of a camera, and in this case specifically the pinhole camera. But always remember that regular mirrors produce virtual images. And any sorts of camera, or if you have a convex mirror, then it produces a real inverted images. Yeah, that's all you need to know for this image section. So I will be moving on. If no one has any questions at this moment, then I'll be moving on to magnetism, talking about how magnets and how the poles work. So yeah, so let's get going. So what is magnetism? So magnetism is a physical phenomenon where materials exert an attractive or repulsive force on each other through the invisible magnetic field. So, the magnetic field actually comes from this. So, everything is made up of tiny particles called atoms. And we have studied this, right? And electrons move inside the atom and move electricity. And moving electricity also creates magnetism. So each electron makes its own tiny magnetic field. So it spins around in certain directions. The electrons spin around in certain direction. And that creates a magnetic field. So for example, if the spinning of the electrons match the spinning of another pair of electrons, then the magnetic field becomes stronger and the material becomes more magnetic. But if we have a case where objects, electrons, spin in the opposite direction, then it will weaken the magnetic fields. But just know that for magnetism, it is the attractive or the repulsive force against each other. So like we know, every magnet has two opposite ends called the North Pole and the South Pole. So you may know the picture of a magnet has this letter N and this letter S. So N represents the North Pole and the S represents the South Pole. And these poles are the points of greatest magnetic field strength. So it is really at the polar side, at the very end. And a magnet, so we have opposite poles attract, while like poles repel. So always think of opposites. Opposites attract, and like repels. So this is always something that you should keep in mind. So when you have a north pole and a south pole together, it attracts to each other. But if we have things like north and a north, then they repel. So opposites attract, likes repel. Okay. And like we've seen, a magnet has an invisible area around it called the magnetic field, where we've seen is produced by moving electrons. And this field is where the magnetic force can be felt. So for Earth's magnetism, the Earth itself acts like a giant magnet due to its iron core. So that's why we use a compass needle to point to the north. Because Earth is magnetic, we can use a compass to locate our position based on the Earth. That's why we have the north, the east, and the south and the west. Okay, so that was about the Earth's magnetism. And we don't have to think about it at a very large scale. Magnets attract objects made up of iron, nickel, or cobalt. So they do not attract things like plastic, wood, or paper. So let's look at types of magnet that there are. So there are permanent magnets in which they stay magnetic all the time. So things like a fridge magnet. There's also a temporary magnet where they become magnetic only when they're near another magnet. So you can see in this picture that the nail and the paper clips are temporary magnets. only when the magnet is present, they act as another magnet. So there's another type of magnet called the electromagnets. So this is made using electricity, which produces a very strong magnetic field. And it is used in motors, generators, alarms, microwaves, MRI scans, etc. Things like loudspeakers, doorbells, microphones, all of these use electricity to produce magnetism, and this is how everything inside works. So they all use electricity and magnets. Okay, so let's look at this question. Which of the following sets of devices operate on the principle of magnetism? So we've looked at a couple, but which of these do you think is the correct set? Yeah, if you said A, I think I heard A, and if you said A, that would be correct. But we didn't quite talk about what this is. So what is an LCD TV? So LCD refers to liquid crystal display, and this material of TV does not use magnetism to create the image. It uses liquid crystals to display images. So just know that LCD is not related to magnetism. So whenever you see an LCD TV option in a magnetism question, you know that it does not use magnetism. It just uses electricity, but it does not use that electricity to create a magnetic force. It just uses the liquid crystals to display the images. But on the other hand, things like loudspeaker, yes, they use magnetism. Compasses, of course, they use magnetism. And even alarms, they use magnetism. The electromagnetism, remember? Where we use electricity to create magnetism. Okay, so all of these options were magnetism, use magnetism, except for LCD TVs. Okay, so here are some more examples of electromagnet applications. Things like electric doorbells, electric locks, loudspeakers, earphones, microwaves, alarms, even magnetic trains, and of course the compass. Okay, let's see if anyone can answer this theory question. So, what is a magnetic pole that we were talking about? So, what is a magnetic pole? Does anyone know the answer? So, what is a magnetic pole? So we have a magnet like this, right? And the poles are both ends. So both ends are poles. So what is exactly the magnetic poles? Well, they are the extreme opposite ends where magnetic force is the strongest. So, like we've seen, magnets have two poles, the North Pole and the South Pole. And each of these poles is where the magnetic force is the strongest. So we can look at this image that we've seen over here. So we can see all the magnetic fields drawn on this magnet. You can see that the force is strongest at each pole. So always remember that in the poles, there's the greatest magnetic strength. Okay. So we've looked at many uses of magnets. So can anyone name 2 uses of temporary magnets? Or uses of any sorts of magnets that we've discussed today? Yes, that's right. I heard a lot of good answers. Things like house alarms, things like loudspeakers, microphone. All of those, yeah, use magnetism. Whether it be temporary magnets or electromagnetism, but all of them become magnetic when exposed to the magnetic field, and that's how it works. Yeah, things like alarms, buzzers, speakers, and more. Okay, great job. So now we will be getting into some states of matter. We're covering this a little bit late, but I wanted to cover this in this today's chapter, as well as how the object changes from one state to another. So let's look at the states of matter, which are solid, liquid, and gas. Okay. So matter exists in 3 main states, and the matter really is anything that is around us. Even things like air, any objects that we can see and touch are all matter. So first we have solids. And solids are are where particles are tightly packed and they can vibrate in place. So solids have fixed shape and a fixed volume. And solids are things like ice, wood, metal, stone, etc. We also have liquids. And liquids are particles when they're close together, but they can still move around. You can see in this picture that liquid particles are so close, but they move around freely. So they have a fixed volume. You can contain liquid in a fixed volume, but they do not have a fixed shape. Liquids just take the shape of its container. Things like water, milk, oil, all of those are liquids. And finally, we have gases. So gases are when particles are far apart and they move freely. So gases, particles are very far away. What this is called is the intermolecular space, and that space is very far away from other particles. So gas has no fixed shape and has no fixed volume. Examples of gases are things like air, oxygen, steam, etc. Okay, so these are the three types of matters and some of their properties. And here shows some of the comparisons across solids, liquids, and gases. So, solids, in terms of shape, we looked at these options. So we looked at shape, we looked at volume, we also looked at, maybe indirectly, but compressibility, we can talk about that too, and we also talked about density. So in terms of shape, what is the shape of a solid? Well, it is any shape that it can take, but solids are fixed and definite. For liquids, the shape is not fixed. And for gases, the shape is not fixed. Now, can anyone maybe tell me what would be the volume of a solid? Is the volume fixed or not fixed for a solid? So for a solid, is the volume fixed or not fixed, do you think? What does everyone think? Yeah.
The balloon is fixed.
Yes, that is right. Yeah, great job. For the solid, the volume is fixed. So, what do you think for the liquid? For the liquid, is the volume fixed or not fixed, you think? Yeah, what do you think about liquids here? So do you think for liquids the volume is fixed or not fixed? So for liquids, the liquid can change its shape. So the shape is not fixed. So the liquid can take any shape of the container. But the volume itself is fixed. So this is important. So the shape, there is no shape to a liquid. There's no fixed shape. But for volume, there is a fixed amount of volume of a liquid. Okay. What about for gases? Is the volume of gas fixed or not fixed? Yeah.
Not fixed.
Yeah.
Not fixed.
Yes, that is right. Um, the volume of a gas is not fixed. And you can see that the shape of a gas is also not fixed. And this happens because there's too much space between air particles, between gas particles. There's no shape, there's no volume. Okay. And I can walk through the rest. So compressibility just means how much we can press the object. So there's no compressibility of solids because the volume is fixed and the shape is fixed and it's very rigid. So there is no compressibility for solids. There is slight compressibility for liquids, but liquids are also not compressible because volume is fixed. But gases, on the other hand, you can compress gases. Compress means just pushing it down. You cannot push solids and liquids down flat, but you can with gases. Because, again, gas particles are very far away from each other, and the shape and the volume is not fixed. And for the density too, solids have high density, liquids have medium density, and gases have very low density. And this again has to do with the spaces of particles in between. For solids, the particles are very close together, tightly packed. Liquid, they are spread out a little bit. The gases, they're spread very far away. So the density is very low. Okay, I hope this table made sense. So, I'll be moving on to some questions that you can answer as well. So, which of the following substances has a definite shape? So we're talking about shape here. And kerosene is just a liquid. You can think of kerosene as liquid. So what do you think the answer is for this question? What has a definite shape? Definite here is just fixed. So does air have a fixed shape? Let's see. Let's see if air has a fixed shape. So air is a gas. If we look at shapes, the air is not fixed, right? So A is not the answer. Air is not fixed. It doesn't have a fixed shape. What about kerosene, which is a liquid? Let's see. Some of you guys said B, kerosene, but kerosene is a liquid and the shape is not fixed, right? The liquid takes the shape of a container and it does not have its own shape. So it's not B, it's not kerosene. Yes, that is right. If you said C, that's correct. Because stone is a solid. And solids have a fixed and definite shape. Yeah. And the other option, water, is also a liquid, and we know liquids don't have a fixed shape. So the answer is C, stone. Stone has a definite shape. Okay, yeah, great job, everyone. So let's look at this question. Which of the following statements best explains why gases are more compressible than solids? Why can we press more gases and not press more solids? Why do you think that is, of the options? Mm. I'm hearing some answers. Yeah, I think I heard some B's and D's. Maybe I'm mistaking it, but I heard a couple B's and a couple D's. The answer here is D, and that's because here it says particles in gases have wider intermolecular spaces as compared to solids. If we look at this image here, this part is the intermolecular space. So this part right here. You can see that the spaces are very far apart with other particles. Compared to a solid, solids have particles very close to each other. But gases are very far away. That's why if you press it with a piston, like over here, you can compress a lot of the gases, but not the solids. If we said B, gases have fixed volume, but solids do not, I mean, that is true. It is true. Sorry, it's actually not true. It should be the opposite. So gases, here, it's actually opposite. So if we switch, the gases and the solids, this might work out, but you can see that gases does not have a fixed volume, and solids do have a fixed volume. So this should have been the opposite for answer B. Yeah, so gases are easily compressible because the particles are very far apart, so they can be pushed closer together. In solids, particles are packed very tightly and leaves almost no space to compress. So yeah, that was about solids, liquids, and gases and some of their properties. And the final chapter that we'll talk about today is about liquid pressure. Actually, there's one more topic of maybe liquid cycle, but we'll talk about the liquid pressure first. So, liquid pressure is the push that a liquid gives on the sides and bottom of its container. And this happens because liquid has weight and its particles are always moving. So we have this Pascal's law, which we'll get to in a bit. But this just tells you how much liquid pressure that you have. Okay, some of the properties of liquid pressure. So, liquid pressure just means pushing against. So when you think of pressure, if you have like a cup of water or any bottle of water, there's pressure applied to each of the surfaces. It's pressure. So pressure is what the liquid acts. And this property is saying that liquid pressure increases with depth. So as we go deeper down in the cup, all the way down at the bottom, then there is more pressure. So deeper means more pressure. Okay. And the next property is that liquid pressure depends on density. So a denser liquid produces more pressure than a less dense liquid. So more dense means more pressure. More depth means more pressure as well. And the third property is that liquid pressure acts in all directions. So all points of liquid pressure acts either downward, upward, and sideways. So there is equal amount of direction acted upon the pressure. And the fourth property is that liquid pressure does not depend on the shape of its container. So only depth and density matter, not whether the container is wide, narrow, or tall. So it does not depend on its shape. Okay, so we looked at 4 properties of a liquid pressure. So first, remember, liquid pressure increases with depth. Second, liquid pressure increases with density. Depends on the density. 3, liquid pressure acts in all directions. And 4, liquid pressure does not depend on the shape. Now, using these 4 properties, let's see if we can answer this question. Which of the following statements about pressure in liquids is or are correct? So we've looked at 4 properties of liquid pressure. And which out of these 3 are correct? Yeah, maybe I'm hearing some D's, maybe? Or maybe some C's. What do you think? I think I heard 1 D. Yeah. Yeah, I'm hearing a couple answers saying D, but the answer is actually A. So let's look at the reason why. So A says 1 only. So pressure in liquids at the same level acts equally in all directions. That is right. That's correct. Number 1 is correct. What about number 2? Pressure in liquids depend on the area of the liquid. Actually, that is not the case, that pressure in liquids act on the area of the liquid, because pressure in solids depend on the area of the solid, and liquid does not depend on the area of the liquid. It depends on the area of the solid in which it is pressed against. And finally, pressure in liquids decreases with depth. That is not correct. It's not decreasing with depth. The pressure in liquids increase with depth. So that is why number 3 is not correct. And the only answer is 1. So that's why the answer is A, 1 only. I hope this makes sense. And yeah, let's try another question. So this is a Similar question, and it asks, which of the following statements about pressure in fluids are correct? So let's try this one. What do you think the answer is? So maybe I'm hearing a couple D's. Yeah. Um, yeah, if you actually said D, that would be correct. I think I heard someone say D, but yeah, that is correct. Let's see why. So it decreases with depth. Again, no, it increases with depth. Pressure always increases with depth. So one is not correct. What about number two? It increases with depth. Yeah, that's correct. Number three, it does not depend on the area. And yeah, that is correct. The area is not a factor for the pressure of the liquid itself. So the area, like we've seen in the previous slide, the pressure in solids depend on the area of the solid. And in this case, the pressure does not depend on the area of the liquid. It depends on how much area it is pressed against the solid. So it's true that it does not depend on the area. So the answer is D, 2 and 3 only. So let's look at this next question. Which of the following body shapes facilitates movement in a fluid? And we haven't covered this yet, so I'm going to tell you the answer. So the answer is actually the streamline. Sorry, the streamline, which is C. So a streamline is a smooth, flowing shape that helps an object move easily through a fluid by reducing resistance. So if we look at here, this has a streamline body shape. Same with swimmers here. If you have a streamline position, then there will be less resistance of the medium. So just something that you should know is things like cars can have a very streamlined shape, and the swimmer also needs to maintain a very streamlined shape as well. Okay. So let's look at this final question of this topic. So the following devices work based on the principle of pressure in fluids, except for what? Do you think? What do you think the answer is? What does not use principle of pressure of fluid? So, do you know what a siphon is? Siphon actually pulls up water by the use of pressure in fluids. So siphon is correct. And have you guys ever seen a flute? Maybe you've seen or heard the instrument. So remember that maybe some of you have seen or received recorders. Maybe you're familiar with recorders, maybe from other people playing, or maybe you've received one, but it's very similar. Flute is very similar to recorders. But recorders actually use a pressure difference of an air. So here, recorder uses the flow of the air, the principle of pressure of air, and not the pressure of fluids. So it's not a flute. But things like drinking straws and water pumps both use the principle of pressure in fluids. So you can see that the options A, C, and D use pressure differences to move fluids, but a flute produces sound by vibrating the air, and it does not use the principle of fluids. Pressure fluids, that is. Finally, let's look at the topic of water cycle. So let's quickly watch this video, which summarizes some of the processes of the water cycle. Yeah, so this just showed some of the basic water cycles. It goes from evaporation from any bodies of water into condensation and then precipitation back to Earth. So evaporation happens when a liquid slowly turns into gas due to heat. And evaporation happens at any temperature. And some of the common misconception is that evaporation only happens when it's boiling. But it's not. It can happen in any non-freezing temperatures. And evaporation only occurs at the surface of the liquid. So when it boils, what happens is that we're heating the entirety of the liquid. So even particles, the water particles that are inside the water starts to evaporate. That's why you see a lot of bubbles when you boil water. Particles of water evaporate inside the water, basically. But evaporation happens when the surface liquid just goes off, slowly turns into a gas. An example of evaporation is the wet clothes drying on a warm day. You know, when you hang your clothes outside, then it'll dry by evaporation. And the sweat evaporates from the skin that helps cool the body. That's another property of evaporation. I mean, another way evaporation is used is when the sweat evaporates, and that cools your body. And the puddles drying after the rain is also the process of evaporation. Okay. Next was condensation. And condensation happens when warm water vapor or gas particles cools down and turns into liquid droplets. This happens when gases loses heat and they form tiny water droplets. So you have a lot of warm vapors in the air, which are gases, and condensation is the step where it just cools down and turns into liquid. Examples are dew formation, foggy windows, water droplets on cold drinks, and cloud formation. All of these are examples of condensation. And there is another step called precipitation that we didn't talk about in this slide. But precipitation is basically just, it happens in the water cycle, and it happens after condensation when water comes back or drops back to Earth. That process is called precipitation. But the general liquid to gas and gas to liquid can be described with the process of evaporation and condensation. So let's look at this question. Steam changes to liquid by a process called what, do you think? So gas to liquid is a process called what?
B.
Is it evaporation or condensation? So we talked about these two, right? What do you think, A or B?
E or D.
We can look at the previous slide here. So evaporation happens when we go from liquids to gas. And condensation is what happens when we turn gas to liquids, right? So what would be the answer?
And the answer is B. Condensation.
Oh, I cannot hear you for some reason. Let me see.
The answer is B.
Oops. I think maybe it's the
Condensation.
problem with the microphone, or because I cannot hear you entirely. Let me see.
The answer is
Maybe can you try to mute and unmute again? Maybe.
Okay, now you can come.
the answer is B.
Yeah, for some reason I'm still not hearing it, but okay.
Yeah, JB. She said the
I still
answer is
cannot
B.
hear you.
Condensation. You can. Hello. Hello. Can you hear me?
No, I still cannot hear.
Wow.
Maybe can you type out through the chat, or
Okay.
okay. Oh, okay. Yeah. She said the answer is B, and yeah, that would be correct. And yeah.
Okay.
Thank you for letting me know through the chat.
Sure.
Yeah, for some reason, if you if you guys can hear me, I think that is okay. Maybe if you have an answer, you can type it in chat. But
Sure. Can you hear me? Hello. Can you hear me?
like she said, the answer is B, condensation.
Yes.
That
Yes.
is the
Yes.
process
Right.
where gases turn into liquids, right here, this process. So let's look at this question, if anyone has an answer. So a person urinates more often in a rainy season than in a dry season because of what, do you think?
The person.
So yeah, this is the last question, so
Last
maybe
question.
if anyone would like to answer this
The
question.
answer is what? Yes.
Yeah, I will help through this question if um no one is willing to answer. So yeah, it's okay. I think this might be a little confusing because a person urinates more often in a rainy season, but we've only talked about how sweat evaporates from the skin. So urinating often signifies that you have more body fluid, right? You have more fluid and water in your body. That means anything that has less water or less liquid can be crossed out. And of course, it's not the case that his kidney works faster. It's not that he drinks less water. If you say he drinks more water, it would work. But less water means that he would urinate. The person would urinate less. Now we have options A or B. So what allows a person to contain more liquid? It will be the option B, right? Less sweat evaporates from the skin. And if less sweat evaporates, then we will have more water in our body. And if we have more water in our body, then we will urinate more. A is not the answer because if more sweat evaporates from the skin, then there will be less body fluid in our body. So we will urinate less. So that's why the answer is B. When you sweat a lot, the body loses more water. So the kidneys produce less urine. Yeah, this was the last BECE question for today. So, yeah, thank you everyone for listening. And do you have any questions for me today? So, any questions? I think you would have to maybe type in the question if you have any in the chat.
Hello. Can you hear me?
I still cannot hear you.
Wow.
Let me see.
Wow. Then what is happening? Okay.
Okay. Yeah, that's okay. If they have no questions today, then I think do you I think today will be the last lesson of the year, or if you want maybe another lesson next week, we can do that too, or maybe next Thursday, and I think maybe not next Friday, or
Next Thursday will be vacation. Hello.
sorry, yeah, can you maybe type out because I cannot hear you
Okay.
still.
Okay.
Yes.
Okay.
Oh, okay. So next Thursday will be vacation. Okay. Um, or when does your vacation start? Because if it starts on Thursday, maybe I can have another lesson on Wednesday, but it's okay if we don't meet. This can be the last lesson if you want to. But if you want to meet or have a lesson one more time, then we can do maybe next Wednesday or
One of the would that be fine with you?
I think um because of the time difference, um I don't think the earlier might work for me. So today can be the last lesson. It's okay if um if you really want to, I can meet on Wednesday, or if that doesn't work, um we can still meet next year. So if we meet next year, will it be on January 16th? Is that the end of the vacation? Or yeah, okay. Please send me an email if you still want to meet, and I think we will just prepare a lot of questions to solve that day. Yeah.
All right.
And sorry, when does the vacation end for the students? Um, when does school start again? Yeah.
Yɛbɛbie school time bɛn? Yɛbɛbie school time bɛn? 8th January.
Oh, sorry, I think I meant when does vacation end for the winter vacation and not for the summer, yeah, vacation. Yeah. Oh, so would that be January 8th, right?
January.
No.
That is
Just
on
so that I'm
January.
not mistaking it. Yes. Will that be correct? Uh, um, yes. Will that be on, sorry, will that be on January 8th? Okay. Okay, great. So we will probably start on the 16th of January. So lessons will be the 16th of January. Okay. So we will probably start our lesson on the 16th. Okay. And have you decided on the topic that the students want to learn next year? Will it be agriculture or math, or English. Yeah. Oh, okay. Oh, okay. They chose mathematics. Um, okay, so sorry, what is SIC again? Um, that be oh, sciences. Okay. Yeah, we can continue with mathematics and sciences after we do agriculture because we will do agriculture first and then yeah, move on to mathematics and more science. Okay. Okay, yeah. Okay. Yeah, thank you and please email me if you want to meet maybe next Wednesday um or if not, then I will probably see you next year at January 16th. Okay, yeah. You can maybe send me on Monday. Okay. Yeah, thank you. And
No.
yeah, bye. I'll share you the slides too. Yeah.
All right. All right.
Okay. All right.
Same.
Thank you. Bye.